already we have studied this various phases. Okay, lexical analysis, syntax analysis, semantic analysis. The phases of the compiler already we have completed. The part of this phases of a compiler is your parser. Okay. So parser, what it will do is first it will consider the language. Okay. The lexical analysis first phase, which will convert that into tokens. Then we have to check whether the sequence of tokens matches with the specification, that is a given input, and we have to identify any errors in that. Okay, so that is the parsing, and then here we are going to see the one type of grammar that is called as context-free grammar. Okay, the context-free grammars, which are all very much useful to understand your syntax in the given language and modify, or if there is any correction, any error, it will detect and develop the program. Okay, so this is a simple example for context-free grammar. So that is a set of terminals called tokens. So this already we have seen the given list of the given language. First of all, we have to categorize that digits and any alphabets which are available there. Okay, a set of terminals called as tokens. After that, we can't able to divide it. Okay, so that is called as tokens. So terminals are the elementary symbols. And similarly, a set of non-terminals, these are all called as non-terminals on the left-hand side part. Non-terminal further categorized into or synthesized into the terminals. And also the set of productions. Set of production is the rule we have to apply in order to get the grammar. And this is going to be started with a start symbol. So these are the four things available in the context-free grammar. So here, productions, derivation, and language. So here, the context-free grammar, you have two parts. One is the left side, or it is called as a head, and the right side, which is called as a body. Okay. Suppose if you are given with any of the expression 3 plus 1 minus 0 plus 8, this is the given expression through the parser tree. Okay, we can able to evaluate it. Okay, either from bottom up or from top down. Okay, so here it is bottom up. So 3 plus 1, 3 plus 1, then minus 0, then plus 8. It will go on up. And finally, we'll get the output after performing this result with the addition of 5. Okay, so that can be done with a parse tree. So this is a pictorial representation of your regular expression evaluation. Okay, and one more thing is here we have the plus and minus, only plus and minus here. The precedence of both plus and minus, they are same here. So there is no problem here. But what happens when you have a different operators, for example, star and plus, which are all coming together without any brackets here. Okay. Here, while you are going to evaluate this expression, if you are going to, normally we are evaluating the expression from left to right. So if you are going to evaluate from the left to right, means x plus y star z is wrong. Actually, the star and the slash having the higher precedence over plus and minus. First is the power, second is star and slash, division and multiplication, and then after that only plus and minus has to be executed if there is no brackets here. Okay. So the precedence, which is very important. So first this is going to be x plus y plus z, x minus y minus z. Means you can apply the associative because everything is same precedence. Associative, either x plus y plus z, x minus y minus z you can do, or x minus y minus z you can do. So associativity, which is going to be applied here. So that is no problem if you have a same operator. Okay. throughout the expression. And then we have we need to write the grammar for the expressions. So this is a simple sample grammar which is given here. In grammar itself, we have two types of it: ambiguous grammar and unambiguous grammar. Ambiguous grammar and unambiguous grammar. So precedence not encoded here. Okay, A plus B star C. The precedence which is not given. So this is one type of ambiguous. Here A minus B minus C, even associated not encoded, you can go either right to left or left to right. Okay. So these two are called as ambiguous grammar. What way we have to proceed. But unambiguous is so this, like this you will get E plus E minus T. There will be only one execution here. Okay. So these are coming under the unambiguous grammar. So these first two, this is unambiguous, and the next unambiguous grammar you have this we have seen already, and this is called as a non-left recursive grammar. Okay. So here the operators which are preceded over your operands, that is T plus E dash actually. So this can be done with the non-left recursive grammar. Okay. So this we can able to solve with the top-down parsing that we will see next. And then we have a sentential form. So this is the grammar given. And this is a sentence string minus identifier. These are all the variables. And you have to derive it. Okay? You have to apply this number ID for this because this is a terminal one. So what way we can go? That is E can be replaced with the minus E. Minus E can be replaced with the bracket. Okay? Minus of bracket E. Then that is going to be replaced with the E plus E. Okay? Then further E will be replaced with the your identifier, left and then right. Okay? So this is a sentential form. And similar way, we are getting the final sentential. Okay? So each and every step we have two choices. One with the non-terminal, another with the and one more is which production we can able to apply. Okay. So for example, here E directly you can go with selecting bracket E. Either you are going to choose bracket E or minus E. Okay. So different two choices are there. But this is the correct one. First we have to go with minus, then we have to go with the bracket. Under which production, each and everything is a production. It is a rule. So which order we have to choose it. So this is called as a terminal and others they are called as a non-terminal. Either we are going to choose the non-terminal or directly is it possible to apply the terminal. Okay. So these are all the things. And there are two derivations here. One is the leftmost and the another one is the rightmost. Leftmost means in the part tree, you have to go, we have to complete the left side part. So that diagram is also given here. For example, E, then we have replaced the E with minus E. Okay, second one. Then third, we are replacing E with the bracket. Okay, left and right bracket. And then E will be replaced with plus E plus E. So that also we have replaced. And finally, in that leftmost, we are deriving first. Okay. Yeah. So E plus E, this E will be replaced with the ID. And similarly, right side will be replaced with ID. Okay, this is called as leftmost derivation first. Complete the leftmost derivation first, then go for the rightmost derivation. The opposite is first we have completed the rightmost derivation, then we have to come for the leftmost derivation. Okay. So these are the two things. It is called as a leftmost derivation and a rightmost derivation. Here, leftmost first this ID will be replaced. Rightmost means this ID will be replaced. So the rightmost derivations are called as also called as canonical derivation. Okay. And then parse trees. So this already we have seen. Okay. So parse tree is one nothing but the pictorial representation of the order in which we are going to uh, execute the expression. Okay. It will be very easier. And then we have uh, context free versus regular expressions. Okay. So this is your regular expression, and this is your